So this video is going to show you how to conduct a related t-test in SPSS. The related t-test is also known as the dependent t-test, paired samples t-test and the repeated measures t-test, but it all means the same thing. It's all the related t-tests, which we're going to work through now. So what is this related t-test? The related t-test is used to compare the differences between the mean scores of two related groups. It's a test of difference used for a within subject or repeated measures design. So whereas the independent t-test compares the mean scores of two independent groups, the related t-test looks at the difference in the mean scores from the same participants but their performance in two different conditions and determines if the difference has occurred by chance or not, and whether we accept the null or the alternative hypothesis. So once you're confident that you've met the assumptions of the related t-test, you can begin the analysis. If you're not sure what these assumptions are, or if your data meets them, have a look at our video on assumptions of t-tests before you begin. So let's look at some data. So you'll see here we've got 15 participants, and these are represented by the row numbers here. So we've got 1 down to 15 participants. We then have the scores for each participant here in these two columns, and this is their scores before and after a lesson. The researcher in this case was interested in whether the students' scores were different on a maths test before and after they'd had a stats workshop. So each student did a maths test, then they had a stats workshop, then they did another maths test. And the researcher was interested in whether there was a difference between these two scores. So the data's been collected and we're happy with the layout of it on SPSS. So now let's run the related t-test to see if there's any difference between the pre and post scores. So to do this, it's really simple. You click Analyze, Compare Means, and then the Paired Samples t-test. So what you'll see this brings up is the Paired Samples t-test box. It's this paired variables here that we need to make a change to. So this just basically asks us which two variables we're interested in. In the case of this data set, we've only got two lots of information anyway, so these both go across. So 1 into variable 1, 1 into variable 2. If you had lots and lots of different columns of data, you might want to do multiple related t-tests at the same time, so you could add those as new pairs. But in this case, we're just interested in one pair, variable 1, variable 2, and they're in there like that. So we click OK. And then this opens up the output. So if you remember, we were interested in whether the scores the students got on a test were different before and after they had a stats workshop. So these output tables will help us to answer this. It's really important that you can not only click the buttons to get here, but that you can actually read and understand what these tables mean. So for the related t-test, you'll end up with 3 different tables. The first is your descriptive statistics. This should all be quite familiar information. We've got the 2 conditions here, so pre-lesson and post-lesson scores, and then we've got our mean for each of those conditions, the number of participants in each of those conditions, and then the standard deviation and the standard mean error. Then the third table, this one here, the paired sample t-test, is the results of the t-test. So this table gives us the mean difference between the two conditions, which is here, minus 6.20. So the difference between this mean and this mean is this amount here. Also gives us the standard deviation, which is here, the standard error mean, and then the next 2 columns gives us the confidence intervals. The confidence intervals basically tells us with 95% confidence that the true mean lies between this lower and upper boundary. So we've got the lower boundary here of minus 8.3 and the upper boundary of minus 4.09. What we're saying is that with 95% confidence, our mean difference sits between these two. We then move across to the t-statistic, the degrees of freedom, and then finally the p-value. So the t-statistic here is minus 6.315, degrees of freedom is 14, and then our p-value, which is labelled as sig two-tailed, is 0.000. It's this p-value that tells us whether the difference we observe between the means of these two conditions, so pre and post lesson scores, whether that difference is significant or not. And in this case, this value is 0.000, which is less than 0.05. So we can say that yes, this is significant. The difference between these two means is statistically significant. If this value was greater than 0.05, it would not be significant. So now let's have a look at how we write this result up. And try to get the two side by side if we can. So there we go, we've got our output table on the left hand side here, and then how to report the related t-test and APA style on the right. So it's always key when writing up the analysis to mention the type of test conducted, the variables, mean scores, standard deviations, and the outcome of the analysis with the test statistics as well. So that's what I've got here in this box. It's also not uncommon to report the confidence intervals, which are here on your output. So check the APA guide for how to include these if this is a requirement for you to do. One of the final things to remember as well is that when we get this significance two-tailed of 0.000 like we have here, it's really important that we report it as P is less than 0.001, so we don't report it as P equals 0.000, it's always less than 0.001. And this is because SPSS rounds this number up to 3 decimal places, so we can't be sure that this number is actually a true zero. So somewhere down the line there might be another number, so we always report it as P is less than 0.001. We can be confident with that. So reporting of the t-test here, we've got students' test scores were compared before and after they attended the stats workshop. So we've given a bit of a background here about what these numbers relate to. On average, students performed worse before. So this is our mean test score. So the mean test score before the workshop was 9.07 with the standard deviation than after. So the students after they'd had this stats workshop scored on average test scores of 15.27 and the standard deviation. The results of the related t-test shows that this difference is statistically significant. So we've got our t-value, t, degrees of freedom in brackets, which is 14, that comes from here, equals, and then our t-value is reported here, which comes from here, and then comma, p is less than 0.001, which comes from this significant two-tailed here.